All right, so our next kind of topic in this section is reduction of order. So this case of the repeated root and the reduction of order really go together. So we're going to start with kind of like the general idea. If you know one solution, let's call that one solution y1, you can find a second solution in the form y2 equal to some function v of t times y1. Which makes sense, right? When we think back to the repeated root example we just did, we had the one solution c1 e to the 3t. And then what did we do for that second solution? I mean, we did a lot of work, but all that really happened is we multiplied by what? T, right? We multiplied by the function t. So that's why these two things are related to one another. So, I mean, the question then is, how do we find v of t? And it's definitely challenging. We're going to do a lot of changing of variables, which is not going to be fun, but we will eventually get there. So we're just kind of going to go by example here. So let's say we have the differential equation t squared y double prime plus 3ty prime plus y equals 0. And I give you one solution, y1 equal t to the negative 1. So our goal is going to be to find a second solution here. What do I not like about the form this differential equation is currently in? Yeah, the t squared. We don't really like things in front of our highest order derivative. So I'm going to go ahead and divide everything by t squared just to make my life a little easier. So I've got y double prime plus 3 over t y prime plus 1 over t squared y equals 0. And then off to the side, we're going to make sure to note that now this means that t cannot equal 0, right? Because we divided by a t squared. And then from this general idea, I know that y2 is going to be some function v times y1, which means y2 is going to be v over t, some form of that. Because I've t to the negative 1, so I just threw it in as a fraction. Okay. This is what I know about y2. And I know y2 has to be a solution to this differential equation. What does it mean to be a solution to the differential equation? Sometimes struggle with that. What it means to be a solution is if I take all my derivatives and substitute them into the equation, I should get like a true statement. So in this case, if I substituted in and simplified everything, I should get 0, right? That's what it means to be a solution. So let's go ahead and take some derivatives. So y2 prime is going to equal v prime over t minus v over t squared. And then y2 double prime is going to equal v double prime over t minus v prime over t squared. minus v prime over t squared plus 2v over t cubed, which if we simplify that, gives me v double prime of t minus 2v prime over t plus 2v over t cubed. Okay, so now I know all these things about the form v2 is going to take, right? So what do you think my goal was with taking these derivatives? Yeah, I'm going to substitute them into my differential equation and solve. So if I substitute in, let's see, I'm going to have v double prime over t minus 2 prime over 2v prime over t squared plus 2v over t cubed plus 3 over t times my y prime, which is v prime over t minus v over t squared plus 1 over t squared times my y, which is v over t, and all of that should equal 0. Let's see. I'm going to go ahead and distribute and then kind of gather my like terms together. So I've got my v prime over t, and then all my v prime elements are 2 over t squared minus 3 over t squared. And then all of my just v elements are 2 over t cubed minus 3 over t cubed plus 1 over t cubed equal to 0. And then something really nice is going to happen. We're going to have a lot of things cancel out. Everything in that v component is going to break down to 0. So I'm just left with v double prime of t minus v prime over t squared equal to 0. So it looks a lot simpler, but I still need to find v. That's the goal. Any thoughts? We're going to use a very fun trick of just renaming things. Yay! More letters to keep track of. Let's let W equal V prime. So what does that mean W prime equals? V double prime. So now I've got Y prime over T plus, not Y, W prime over T plus W over T squared equals 0. Why on earth would I want to just rename letters? No idea. We're shaking our heads in defeat. The goal is to solve this differential equation. We're at only one prime. What two things do we have to solve for only one prime? Separation of variables and integrating factors. This is separation of variables problem. You actually probably could make this a separation of variables problem. I did not. I went the integrating factor route, so we're going to follow my notes. But you could probably turn this one into a separation of variables problem because you have that 0 on the right. So you'd be able to move W over T squared to the right and then divide both sides by W. So it would work out. But we're going to go integrating factor. But first, before I go with integrating factor, I want just, like, I don't want anything attached to my W prime. So I'm going to multiply everything by T. And I get W prime plus 1 over TW equals 0. So my integrating factor, mu, is going to be e to the integral of 1 over t dt, which gives me e natural log of t, which is just t. Partially why I did this, it's not a hard integrating factor one. So if I multiply through by my integrating factor, I've got t w prime plus w equals 0. Undo the product rule. TW prime equals 0. So TW equals the antiderivative of 0 is a constant. And so we've got W equals C over T. These problems really start to like telescope in on themselves, right? We break it down to a new problem and a new problem and a new problem. And now we've got to put it all back together. Because now I finally figured out what W equals, but that was not the goal. The goal was to figure out what Y2 was, right? So let's see if we can break this down even more. So I knew that V prime equaled W. So since V prime equals W, that means V prime is C over T. So what is V going to be? Yeah, just integrate. So C natural log of T. And then what was the relationship between Y2 and V? C over T. Perfect. So Y2 is going to be C natural log of T all over T. Whew. So I know a long problem. But let's like kind of go back and just like think through what steps we took, right? Kind of our first step, if I go all the way back up to the top, was to say Y2 was going to be V times a Y1. That was kind of my step one. And then I substituted everything into my differential equation and simplified down to get this new differential equation to solve. And then the question was, how do I solve this new differential equation? You can solve this new differential equation however you need to solve it. The easiest way for this problem, I thought, you might disagree, was to do a change of variable and then use an integrating factor. So what we're really doing is we're reducing this to a new differential equation problem and figuring out how to solve that. But that's kind of the fun with this. At least I think it's fun, but there's kind of a lot of paths that you can take. So it's not always going to be you're taking an integrating factor. There might be an easier way to take that differential equation. All your double primes may magically cancel out, and then you already have a first order, and you know how to solve that. Okay. So stop the recording.